Romex, also known as non-metallic sheath cable, is permitted in suspended ceilings of large supermarkets constructed of steel given that certain conditions are adhered to. These conditions are primarily based on safety and compliance with the National Electrical Code, or NEC. Firstly, the ceiling must not be a return air plenum. A return air plenum is a space specifically designed within a building structure, often in the ceiling or floor, to facilitate the return of air to the heating, ventilation, and air conditioning or HVAC system. This contrasts with ducted return systems where air is channeled back to the HVAC unit through enclosed ducts. In a plenum, the structural space itself serves as the pathway for air return. The NEC restricts the use of Romex in return air plenums due to the potential fire hazard. Electrical current flowing through Romex generates heat, and in an enclosed plenum space, this heat can elevate the air temperature to dangerous levels, potentially igniting combustible materials or causing the Romex insulation to degrade. Therefore, ensuring the ceiling is not designated as a return air plenum is a critical safety measure. Secondly, the Romex installation must conform strictly to the National Electrical Code. The NEC serves as the authoritative standard for electrical installations in the United States, providing comprehensive guidelines to ensure safety and proper functionality. Several aspects of Romex installation are governed by the NEC. Firstly, the type of cable permitted. The NEC specifies the appropriate type of Romex cable based on factors such as voltage rating, conductor size, and environmental conditions. Using the correct type of cable is essential to prevent overloading, overheating, and other potential hazards. Secondly, the minimum bend radius is essential. The NEC mandates a minimum bend radius for Romex cables to prevent damage to the conductors and insulation. Bending the cable too sharply can cause stress and cracking, compromising its integrity and increasing the risk of electrical faults. Thirdly, the NEC specifies the maximum allowable length of Romex runs without support. Exceeding this length can lead to sagging and strain on the cable, potentially causing damage over time. Adhering to the NEC requirements for cable type, bend radius, and support intervals is crucial for a safe and compliant installation. Thirdly, physical protection of the Romex cable is paramount. Romex is susceptible to damage from crushing, cutting, or puncturing, which can compromise its insulation and expose the conductors, creating a risk of electrical shock or fire. To mitigate this risk, the NEC mandates that Romex be protected from physical damage. The most common method of protection is to enclose the Romex within a conduit. Conduit provides a rigid, protective pathway for the cable, shielding it from impact and abrasion. Alternatively, other types of protective enclosures, such as raceways or cable trays, may be used depending on the specific application and environmental conditions. In addition to these NEC requirements, it is important to consult with the local building code authority in Cleveland, Ohio, to ascertain if any additional regulations or restrictions apply to Romex installations in suspended ceilings. Local building codes may have specific amendments or interpretations of the NEC that are relevant to the project. Furthermore, the local authority may have additional requirements based on local environmental factors, building types, or occupancy classifications. Verifying compliance with both the NEC and local building codes is essential to ensure a safe, legal, and reliable electrical installation. The NEC Article 334 covers non-metallic sheet cable types NM, NMC, and NMS. Section 334 10 addresses uses permitted and specifies where these cables are allowed to be installed. For example, it states that type NM cable is permitted for both exposed and concealed work in normally dry locations. Type NMC is permitted in dry, moist, damp, or corrosive locations. Section 334.12 details uses not permitted. This section clarifies locations and situations where non-metallic sheath cables are prohibited. For example, it states that types NM, NMC, and NMS cable shall not be used where exposed to physical damage. This reinforces the need for protection in areas where the cable might be vulnerable. The NEC also provides guidelines on how to support and secure non-metallic sheath cables. Section 334.30 requires that cables be secured by staples, cable ties, straps, or similar fittings designed and installed so as not to damage the cable. Furthermore, the spacing between supports is specified to prevent sagging and potential damage. Generally, support should be placed at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. When running Romex through bored holes in framing members, the NEC specifies requirements to protect the cable from nails or screws. Section 300.4 D addresses this, requiring that where cables are installed through holes bored in wood framing members, the edge of the hole shall be at least 1.25 inches from the nearest edge of the framing member. If this distance cannot be maintained, the cable must be protected by a steel plate or bushing. The NEC provides specific requirements for the ampacity of conductors in Romex cables. The ampacity is the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. Table 310.15. B16 in the NEC provides ampacity ratings for various conductor sizes and insulation types. It is crucial to select the correct conductor size based on the load it will be carrying to prevent overheating and potential fire hazards. Dirting factors may need to be applied to the ampacity ratings in Table 310.15. B16 if the cable is installed in certain conditions, such as in proximity to other cables or in high ambient temperatures. These dirting factors are outlined in NEC Section 310.15. C and are intended to compensate for the reduced heat dissipation capability in these situations. Box fill calculations are another important consideration when installing Romex cables. The NEC specifies the maximum number of conductors, devices, and fittings that can be installed in an electrical box. This is to prevent overcrowding, which can lead to overheating and potential hazards. Section 314.16 provides the rules for calculating box fill. Each conductor, device, and fitting is assigned a volume based on its size, and the total volume must not exceed the box's capacity. Grounding is a critical safety measure in electrical installations, and the NEC provides specific requirements for grounding Romex cables. Section 250 covers grounding and bonding requirements. Romex cables typically include a bare or green insulated grounding conductor, which must be connected to the grounding system of the electrical panel and any metallic enclosures or equipment. This provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Overcurrent protection, such as circuit breakers or fuses, is essential to protect Romex cables from overloads and short circuits. The NEC requires that overcurrent protection devices be sized appropriately for the ampacity of the conductors they are protecting. Section 240 covers overcurrent protection requirements. The overcurrent protection device should be rated to trip at or below the ampacity of the Romex cable to prevent overheating and potential fire hazards. When splicing Romex cables, it is crucial to use approved methods and materials. The NEC requires that all splices be made in a junction box or enclosure and that they be properly insulated and protected. Wire connectors, such as wire nuts or terminal blocks, must be listed for use with the conductor sizes and types being spliced. Improper splices can create high resistance connections, leading to overheating and potential fire hazards. When running Romex through thermal insulation, it is important to consider the potential for heat buildup. The NEC requires that cables be installed in a manner that prevents overheating. If Romex is installed in direct contact with thermal insulation, it may be necessary to derate the ampacity of the conductors to compensate for the reduced heat dissipation capability. Alternatively, the cable can be installed in a conduit or raceway to provide an airspace around the cable, allowing for better heat dissipation. When working with Romex cables, it is important to follow all safety precautions to prevent electrical shock and other hazards. Always energize the circuit before working on any electrical wiring. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC is available for purchase from various sources, such as the National Fire Protection Association and electrical supply distributors. Many jurisdictions also adopt the NEC as their local electrical code, so it is important to check with your local building code authority to determine which edition of the NEC is in effect. Staying informed about the latest NEC requirements is essential for ensuring safe and compliant electrical installations. In summary, the use of Romex in suspended ceilings of large supermarkets constructed of steel is permissible under specific conditions. These conditions primarily revolve around, firstly, ensuring the ceiling is not a return air plenum, secondly, adhering to all applicable requirements of the National Electrical Code, and thirdly, providing adequate physical protection for the cable. Furthermore, consulting with local building code authorities is crucial to ascertain any additional requirements specific to the jurisdiction. By diligently following these guidelines, a safe, compliant, and reliable electrical installation can be achieved. The information provided is for informational purposes only and does not constitute professional engineering advice. Always consult with a qualified electrician or electrical engineer for specific design and installation recommendations.